Staying on top of AI, it just moves so fast, doesn't it? It can feel pretty overwhelming sometimes.
It really can. Blink and you miss something major.
So let's cut through some of that noise. We've dug into the AI Daily News Digest from May 5th, 2025 to pull out the really key stuff you need to know.
Exactly. Think of this as your shortcut to the most important developments right now.
Okay, so on the list today,
Yeah.
we've got Google's Gemini 2.5 Pro apparently beating Pokémon Blue. That's interesting.
Very. Then there's a new benchmark looking at how AI agents handle, real-world job tasks.
Right, moving beyond the theoretical. And the whole RA versus long context debate, we'll get into the details there.
And finally, Apple's move, partnering up with Anthropic for AI coding tools.
Okay, quite a bit to cover. Let's dive right in. First up, Gemini and Pokémon Blue.
Right. So Sundar Pichai announced that Gemini 2.5 Pro completed the game. Big news, but
But kind of light on the specifics, wasn't it? Like, how did it play? Was it just text prompts, or did it actually interact with the game visuals? Any automation involved?
those are exactly the questions buzzing around. Has Claude or another model done this already? We don't have benchmarks, hours played, anything like that.
Yeah, no comparison points. And what's the end goal here? Just beating the game? Or something more ambitious, like, say, completing the whole Pokedex?
That would be a whole other level of complexity, wouldn't it? Require serious long-term planning, resource management.
Absolutely. Way beyond just winning the final battles.
Still, technically, getting an LLM to finish a game like Pokémon Blue autonomously, that's significant progress. It shows advancements in things like sequential planning, strategy, and handling an interface.
Task-oriented AI getting better. And speaking of seeing it in action, there's that live Twitch project, Gemini Plays Pokémon.
Right. That's not just talk. They're actually showing it, using the Gemini Pro 2.5 Experimental LLM.
And their setup sounds pretty sophisticated, pulling data straight from the emulator's memory, screenshots.
Yeah, they convert all that into a format. Gemini can understand spatially gridded representations, they call it. Then Gemini outputs the gameplay actions.
And they're using specialized agents for certain tasks, like pathfinding.
Things like breadth first, search for navigation, solving puzzles. Plus, they summarize past actions to fit the context window limit. Pretty clever.
Keeps the history manageable for long sessions.
And the way they built it is modular. That's smart because it means they could potentially swap in different LLMs later for comparison.
Makes sense. Now, watching it live, people notice the speed issue, right? For non-turn-based games.
Definitely. Pokemon is turn-based, so Gemini can keep up.
Oh.
But for games needing split-second reactions, LLM inference speed is still a bottleneck compared to traditional game bots.
Which are often heavily scripted anyway. Still, there's excitement about generalizing this, maybe to platforms like Steam eventually.
Oh yeah, huge interest there, if the agents get fast and capable enough.
There was that moment, wasn't there, where Gemini's Blastoise, even at a high level, ran into trouble.
Yeah, it ran out of PP power points for its main water attacks in the final battles.
And against the rival's Rhydon, its other moves weren't very effective because of the type matchup.
Exactly.
Yeah.
It shows that even with brute force, well, a high level, you still need strategy. Resource management is key.
So the question remains, can LLMs get fast enough for real-time gaming?
That's the big challenge. Inference speed, reasoning speed.
Yeah.
It's an active research area.
But bottom line, the Twitch project did succeed. Victory Road, the Pokémon League, level 85 Blastoise took the championship.
Quite an achievement. And you can find links to the stream archives if you want to see it.
The community reaction seems really positive, especially the calls to open source the system.
Absolutely. People want transparency. How does the harness work? What guidance is the agent getting?
Right, that whole scaffolding question. How much is the AI and how much is the framework around it? It impacts how we judge the capability and reproducibility.
There was a good piece on Less Wrong about that, how the wrapper design really matters.
And this all feeds into the bigger discussion about standardizing how we benchmark AI in games like Pokémon.
Yeah, maybe a leaderboard detailing the AI, the harness, the strategy. That would allow for much more rigorous comparisons.
Okay, speaking of benchmarking, let's shift to evaluating these agents on more, well, practical, real-world tasks.
Right, because current benchmarks might not fully capture what's needed for, say, knowledge work.
So the agent company benchmark aims to address that.
Exactly. It focuses on objective benchmarks for tasks that knowledge workers do, but in a simulated software company.
So not just isolated tasks, but tasks that take more time, more steps, like a real project, and they measure performance along the way.
Precisely. Granular evaluation of subtasks. And they built this whole simulated intranet to make it realistic.
Using open source tools.
Yeah, things like GitLab for code, OwnCloud for files, Plane for task management, Rocket Chat for communication. They even have little logos in the paper you'd recognize them.
Creates a self-contained, reproducible environment. And they have simulated employees, too.
Engineers, a CTO, HR, the whole setup. The tasks cover software engineering, HR, admin, project management, finance inspired by the ONET job database.
And a key thing is these long horizon tasks with checkpoints. That feels much more like real work.
It does. And their evaluation method is interesting. For structured stuff, they use Python scripts to check things automatically. Did the code build? Was the server launched?
Deterministic checks. But what about less structured things, like reports or messages?
For those, they use another LLM Claude 3.5 Sonnet, actually with specific rubrics or examples to score the quality.
Can you give an example of a task?
Sure. Imagine an agent has to manage a software sprint for a project called Rising Wave. It needs to find unfinished tasks in Plane, move them, message the engineers in Rocket Chat, run code coverage tests, upload the report to OwnCloud, and even handle feedback from a simulated manager.
Wow, that's complex, multi-step, multi-tool.
And they track metrics like the number of LLM call steps and the token costs. Efficiency matters.
The effort to build this sounds immense.
Oh, it was. Over 3,000 person-hours, they said. Designing, building, testing, verifying. Lots of quality control, code reviews, double-checking everything.
Very thorough. And what can the agents actually do in this simulation?
They use something called Browser Gym for basic web actions, clicking, typing, scrolling. But they can also run Python code and bash commands. A pretty broad tool set.
So where do the agents tend to fail?
Some interesting areas. Lack of common sense, apparently, like not recognizing file types.
Yeah.
And struggles with social skills, not following up appropriately in conversations, things like that.
The softer skills are still hard for AI. Did performance vary by task type?
Yeah, significantly. They did much better on software engineering tasks than on things like data science, admin, or finance.
Even though some of those admin tasks might seem simpler, why the gap?
The theory is that LLMs have been trained on tons of public code, so they're better at SWE. Admin and finance tasks often use private company data, which isn't in the training sets. Plus, understanding documents, dealing with people, complex software, repetitive tasks, those are still weak points.
How did different models compare, like open versus closed source?
They tested Llama 3.1 against GPT-4o. Llama generally took more steps, cost more, and had lower success rates. Anecdotally, they felt GPT-4o was better at knowing when to quit if a task was too hard.
Interesting. Okay, let's pivot now. RAG versus long context. This is a constant discussion.
It really is. And understanding the nuances is important. Let's draw on some insights from that Google DeepMind deep dive on long context. Nikolai Savinov was featured there.
Right. He started with the basics. What's a token? We throw that term around a lot.
Essentially, for text, it's usually a word or part of a word, maybe punctuation, slightly less than one word on average. It's different for images or audio, of course.
And why tokens instead of, say, individual characters?
Speed, mostly. Generating token by token is much faster than character by character, though character-level models have been tried.
He also mentioned how tokenization affects how the model sees text, right? The strawberry example.
Exactly. Andres Karpathy talked about this too. If strawberry is one token, asking the model to count the R's inside, it is tricky based just on its token-level view.
So the context window, all the tokens you feed the model, is crucial. Prompt, history, files.
Right, because models have two knowledge sources. The stuff baked in during pre-training in weight memory, and the stuff you provide right now in context memory.
And in context is easier to update. For new info, private data.
Much easier. You just provide it. Short context models struggle to fit everything, leading to competition between knowledge sources. Long context helps alleviate that, offering potentially better recall.
Which brings us to RAG retrieval augmented generation. Can you break that down quickly?
Sure. A RAG is basically an engineering pattern. You take your big document collection, chop it up, create vector embeddings for the chunks. Then you embed your query, find the most similar chunks using vector search, and stuff those relevant chunks into the LLM's context along with your question.
So the LLM gets the question and relevant background info. Makes sense. But why not just build retrieval right into the model, especially for web-scale knowledge?
Well, for huge private knowledge bases, billions of tokens, common in enterprises, RAG is still necessary. The context windows aren't that big yet.
So RAG and long context aren't enemies.
Not at all. They're synergistic. Long context lets you pull more relevant needles from the RAG haystack. Improves recall, The real limit often becomes application latency.
He mentioned the 1 million token goal was initially kind of a marketing number.
Yeah, in the sense that when they started, 128K, 200K was state-of-the-art. So 1 million was a 5x stretch goal. Then they shipped 2 million soon after 10x. It pushed the boundaries.
What's stopping us from going way beyond 2 million now?
Cost, mainly. Inference cost gets really high. They've tested 10 million tokens internally, and quality is good for simple retrieval, but running it is expensive. Chip availability plays a role too.
So is it just about more compute, or do we need research breakthroughs for, say, 10 million tokens and beyond?
He suggested more innovation is likely needed for near-perfect performance at those extreme lengths, beyond just scaling.
And they've seen big quality jumps in Gemini's long context ability recently.
Yeah, comparing 1.5 Pro to 2.5 Pro, significant gains at both 128K and 1 million tokens compared to strong baselines.
Does the quality dip at longer contexts? That lost in the middle thing?
They haven't seen lost in the middle. But he did say quality can decrease slightly for hard tasks with lots of distracting info as context grows. It's an area for improvement.
Is the model really paying attention to everything in a huge context?
Well, attention is a limited resource. Tokens compete for it. Hard distractors, irrelevant but similar sounding info, can pull attention away from the real target. More tokens mean more competition.
So maybe pre-filter the input.
From a research perspective, he prefers improving the model's core robustness,
Yeah.
but practically. Yeah, avoid stuffing the context with totally irrelevant junk. It hurts cost and performance, especially for multi-needle retrieval.
Could the model do the filtering itself eventually?
Perhaps, as models get better and cheaper. Right now it's a balance.
How are they evaluating long context beyond just finding one needle?
That's seen as mostly solved with easy distractors. The frontier is handling hard distractors and retrieving multiple needles.
And distinguishing retrieval from synthesis.
Right. Finding a fact is one thing. Tasks like summarizing a long document, which require integrating info from all over, are better tests of true long context capability. But they're harder to evaluate automatically.
How does long context fit into the overall Gemini picture?
It's crucial. Having dedicated teams is good, but making it easy for other teams to use and integrate these capabilities is just as important.
And the link between long context and reasoning seems deeper than just having more info.
Yeah, better next token prediction over longer sequences helps the model generate its own thinking traces. It can work through more steps, using its output as input iteratively, kind of overcoming network depth limits.
What about generating long outputs, like long articles or reports?
The base models can often do it like copy long texts. But careful alignment is needed post-training to manage the end-of-sequence signal, especially if the fine-tuning data was mostly short answers. Reasoning is one long output task, translation is another. It's ongoing work.
Got it. So best practices for developers using long context now.
Caching. Use context caching heavily if you query the same base documents repeatedly. Saves time and money up to 4x less cost for input tokens. Huge for chat with your docs.
Good tip. Anything else?
Put the question after the context when caching, so changes don't invalidate the cache. Combine long context with R for massive knowledge bases. Avoid irrelevant context padding.
And how to make it prioritize the context over its internal knowledge.
Prompting. Use phrases like, based on the information above, to guide it explicitly, helps resolve contradictions.
What about fine-tuning on a knowledge base instead?
It's an option, can make inference faster, but its downsides. Tuning complexity, overfitting risk, hallucinations, privacy issues, and the knowledge is harder to update later. You might end up needing context again anyway.
Looking ahead, say 3 years, what's the prediction for long context?
Dramatic quality improvements at 1-2 million tokens. Near-perfect retrieval, unlocking new applications. Costs will drop, making 10 million tokens more common. That 10 million window could be a deal breaker for coding, letting AI process entire code bases with near-perfect recall. Imagine that assistant.
Beyond 10 million gets more speculative, needing bigger innovations.
Seems likely. And it's not just about the models. Skilled inference engineers are crucial to make it all work efficiently on the hardware.
And how do AI agents fit in?
Agents are both users and suppliers of long context. They need it to track state and history. But they can also use tools to automatically fetch and pack context, making it less manual for us.
Okay, last topic, Apple's moves in AI coding tools. What's the latest?
Reports suggest Apple is partnering with Anthropic for an updated Xcode.
Anthropic, the makers of Claude, which has a good rep for coding.
Exactly. The new Xcode apparently integrates Claude Sonnet and is being tested internally by Apple employees right now.
Makes sense. Lots of companies are using AI coding tools now. Apple can't really afford to lag.
Seems like their earlier hesitation about AI might be easing, at least for developer tools.
What can this internal Xcode version do?
It reportedly has a chat interface for code help, can assist with UI testing, and help find and fix bugs.
Any word on when third-party devs might get it?
No public launch date yet.
Mm-hmm.
Depends on internal testing, I suppose. If it goes well, maybe they'll offer it more broadly.
This isn't their first try, though. Remember Swift Assist?
Right. Announced last year, planned for 2024, but never shipped. Reports mentioned issues with it making things up or even slowing developers down.
So maybe partnering with Anthropic is their way to get it right this time. Leverage Claude's strengths.
Seems plausible. It fits with their other recent AI partnerships, too. OpenAI for iOS 18, potentially Google, Gemini, Baidu, and Alibaba in China.
Okay, so wrapping up today's deep dive, we hit Gemini 2.5 playing Pokémon Blue, a cool, if vague, demo.
The agent company benchmark, really pushing for realistic agent evaluation.
The ongoing dance between Araj and long context and where that's headed, very exciting potential there.
And Apple making a strategic play with Anthropic to boost their AI coding capabilities.
Lots of movement showing how fast AI capabilities are evolving across different areas.
It really gives you a sense of the current trajectory.
Absolutely. And it leaves you wondering, doesn't it? What does it really mean when AI masters complex games? How profoundly will AI agents change professional work? And what new frontiers will these ever longer context windows open up for how we access and use information? Something to think about for sure.